All right, without further ado, let's kick things off. Please join me in welcoming our first keynote speaker, Tanya Dixit, who will be discussing responsible AI. Tanya Dixit is a generative AI solutions architect at Google, driving AI innovations with Vertex AI and Kubeflow. She's previously led machine learning initiatives at Crayon, focusing on MOPs and cloud platforms like AWS and Azure. Tanya was also the editor-in-chief of the Future Stack, Canberra's first AI newsletter. Let's all give her a warm welcome.
Hey everyone, just give me a second to set up. All right, how are we doing? So yeah, I'm Tanya and I'm a generative AI solutions architect at Google. So today, before I start, I want you to ask yourselves a question. If the future of AI depended entirely on your choices as a developer, how differently would you approach your work? And we'll keep revisiting this question as we go through some of the concepts. At the end of the talk, I will give you my answer, and I would love to know what you think about it. Today I'm going to talk about responsible AI and why responsibility is essential for everyone in a field that's high impact and high velocity. The application part of it is going to be covered by the amazing talks that are coming up, and I'll just cover some of the principles that I apply in my day-to-day. So I want to start off with a personal story. I got into AI machine learning when I was 22, and at that time, I was very lost, did not have a purpose in life, and I spent my free time just buying online courses and binge watching them. For some reason, that was a weird hobby that I had at the time. And I chanced upon this course. It was the Deep Learning Nano degree from Udacity, and Sebastian Thrun, I really admired his work. So I started doing this course, and I had no background in machine learning and just dove straight into deep learning. I really loved the way that was presented, and I could apply the concepts that I had learned, the mathematical concepts that I had learned, to this new field that I had no background in. And that was really, really exciting to me. And it was not just math and code that was exciting. I also saw that as a way to help people. I could see the possibilities of applying my skills to bring about the changes that I always wanted to since I was a little kid. And I realized for the first time in my life that sometimes what you work on is actually much more important than how good you are. So I took the leap, and I sort of changed careers at that point. I would say after diving deep into that field, I was able to find my purpose. And I started feeling that, I'm actually doing something with my life. The reason was my purpose, it sort of evolved, and it started getting connected to what are the products that I want to see my family using. For example, my grandma, she cannot use a smartphone, so she can't really call me, so she has to wait for my call. I imagined a world where she can actually use the new gadgets very intuitively, right? I imagined a world where my sister doesn't have to struggle so much because she has access to personalized education. My parents can look at healthcare data and actually trust it because they can use the insight from that data and apply it in their daily lives. So basically, I imagine a world where people trust technology and they're able to use it for their best interests. Now, all of these areas that I'm talking about, they are very critical areas. They deal with vulnerable people, right? There's healthcare, aged care, education. And in areas where there's this high impact, individuals also have a higher responsibility. So I asked myself, how do I start thinking about developing such applications, such technologies responsibly? And that's what we're going to talk about today. So if you have to take away one thing from this talk, take this idea that developers have much more agency and responsibility in this world, because we're actually in a world where we have access to a very high velocity and high impact technology. And this idea should actually make you very happy because you can create a huge impact on this world. Okay, so today's agenda, I'm going to talk about AI as a multiplier, then a little bit about ethics and responsible AI, the systems approach to developing AI, and then some of the practices that I find useful in my work. So AI as a multiplier, why is AI so powerful? Because it's actually a huge multiplier. And the way it's a multiplier is it not only multiplies human productivity. Well, as a developer, things that used to take me 7 days now take me less than a day. So I'm just flabbergasted looking at that. I'm able to code in new languages without actually learning them. So I actually develop the project first, and then I get to learn the languages, which is pretty interesting. The other thing is it gets better with data, as you already know, with less and less development effort. And then it's also a technology multiplier, because AI systems can create other systems, and it's a self-improving loop. So it's a meta multiplier. We've also seen some emergent capabilities with large language models. So large language models, when they started showing reasoning capabilities, there was research around that, that this is basically an emergent capability. And people sort of interrogated these models to find out later why these capabilities emerged. So I see the difference between other technologies that have existed till now is that they haven't been self-improving, and they cannot scale without a lot of human intervention, whereas AI is able to scale with less human intervention as it gets better. Now, what is a property of such a technology? It's really hard to predict how such a tech is going to evolve, because it's not just a property of the technology. Since it's going to be so widespread, it's a property of the overall system that it's a part of. And this system, it's not just a tech system, right? It's a human system. It's about how humans interact with each other, the dynamics, the social dynamics that we have. It has so many moving parts. And that is why I'm very interested in the frameworks that help us create the agency required to help develop AI responsibly. So that's why let's talk about ethics and responsible AI, because ethics is at the heart of responsible AI. Now, what is ethics about? It's about ensuring trust, security, and promoting well-being. The goal of ethics is to help humanity flourish. And when we think about AI ethics, it can seem that it's subjective, it's messy, so it's something that we do not want to think about or do not have a proper framework to apply. But that's not true. And that also does not absolve us from the responsibility of using ethics. I agree that there are multiple valid approaches to ethical challenges, and it's also very subjective. But then ethics are not purely subjective. It's actually, at this point, it's a well-researched science, and we can point to things that are ethical and that are not, at least in specific situations, specific contexts, and specific applications. Also, when it comes to ethical responsibility, I see it as a shared responsibility. It's a responsibility of the team that is developing the specific application, the individuals that are part of it, and it's not just society's job, it's an individual responsibility. We're all active participants in creating ethical AI. And as I touched upon, it's also intertwined with the entire system. So that's why I want to talk about the systems approach to AI. So when we think about technology, it doesn't really exist in a sandbox, right? It doesn't exist in isolation. The system approach talks about technology being deeply embedded in the fabric of our society. So technology it's actually a form of power if you think about it, right? Because when we build something, we're giving power to a particular community, and it's possible that we're taking away from another community. So those are the things we do need to think about when we're developing something. Now, whenever there's power involved, wherever there are power dynamics involved, there are always ethical implications. So we must ask when we develop something, whose power are we increasing? Whose power decreases with this technology? And even if sometimes we think that this tech doesn't really impact power balance, but then we cannot foresee every consequence. We cannot foresee unintended consequences. So that is something we should be thinking about, and we must make an effort to anticipate unintended consequences. We need to think about how technology influences social patterns and behaviors. What are the patterns that it's feeding into? What are the patterns that it's taking away from? And is that the dynamics that we want future generations to have? Do we want to break certain dynamics? Will something I develop help or hinder people? We need to evaluate whether this tech will help certain groups and hinder certain others. Now, at the heart of this approach is human responsibility. And it's not a hands-off approach, because technology is not something we just goes into the world and it shapes society on its own. It's actually in our hands, very much in our hands. The future is not predestined. The technologies we create and how we choose to deploy them will actually determine whether we move towards a more equitable future or one fraught with deeper divides. So now I'm going to dive into some of the responsible AI practices. Now, there are many frameworks for thinking about this. Google has its framework as well. Today, I'm going to talk about things that appeal to me and things that I use just while building applications or thinking about some of the applications that I touched upon before. So the first one is user-centric development. So this is very much aligned with Google's AI principle one, which is being socially beneficial. This ensures that user is at the center of our development. Now, whenever I start a project, I do like to think about my user, how they're going to use any product that I build, but also what are the current workflows that my user has, right? For example, I was working on a bushfire risk assessment model. It was to be used by government agencies for assessing bushfire risk, for mitigating risk, for analyzing whether to conduct bushfire risk assessment and reduction activities. And we spent a long time in understanding what data sources were the stakeholders using, what do their business processes and what do their day-to-day processes look like, how do they make their decisions, and how are they going to use the tool that we are building to make decisions. It was important for us to understand how do they utilize this information, because that would affect a real-world decision. And that would help them decide in deciding to conduct any bushfire risk reduction activities, the frequency of it, the location of it. And this also helped us understand the level of explainability we wanted in our models, the level of the kind of data that we needed to train our models, the model that we were actually going to use. So these are all the considerations that we understood when we talked to our users. Another thing is defining the metrics, because when you are building something, how do you know whether it's a successful product or not? You define the metrics early on, and that's very much dependent not just on the problem that you're trying to solve in terms of whether it's a classification task or a regression task, right? It also depends on how your end users are going to use it, and are you actually aligning with the end users and their use case. At this point, I also like to think about the unintended consequences of what I'm building and then how that's going to be used. It's also important to gather feedback at this point. And this feedback can just be, well, if we build it this way and this is the information that you're getting, how would you actually use it? And how would you tell us that this information is good or not? It's very important to do that. User-centric development is also about communication, because a system can never be perfect, right? So it's also important to communicate the limitations of your system, of your data, of the data that you collect, and of the model to the users, so that they know when to rely on the system and when to rely on their own decisions. One concept that I find very interesting here is transparency and fairness. So that's something that depends on the particular application. If your application really has higher transparency requirements, that's something that you would discover at this stage as well. The next one is data interrogation and limitations. AI models are highly dependent on the data they have been trained on, and it's difficult to build systems that are fair across all situations, contexts, and cultures. But it's very important for us to examine and validate the raw data for representativeness and bias, because that, again, that tells us what are the applications that I can use this data for. And when I'm aware of the data limitations and understanding, when I'm aware of the data limitations and the inbuilt assumptions in the data, one way I can be responsible is communicate these limitations to my stakeholders and make them aware these are the situations you can actually use this data, and these are the situations you should not be using this data for. So one way to communicate that is using data card templates, and I'll show you some of the artifacts later. Another practice that I think is very important is to monitor input data. So input data can change, and you might have built a system under certain assumptions. If you monitor your input data for drift, this gives your system added reliability, because if the input data changes, your system will have unintended consequences. So one of the examples is this. You can see on the left, the message is, be careful, it's after 6 p.m. and our run route recommendations don't include streetlight data. So it's very transparent. So when the user looks at it, they're like, okay, fine, I understand why the recommendations, they may not be accurate. And on the right, it just says, be careful on your evening run. So you can see how transparency can directly affect trust with the users. This is an example from Google's People and AI Guidebook, so feel free to look it up online. Then one of the examples of a data transparency artifact is the data cards playbook. Now this playbook I really love the way it's structured, because it gives you the summary, it gives you the data lineage, but it also tells you about, let's say, motivations and intentions of this particular data set, the intended usage of the data set, what it can be used for, what it cannot be used for, as we discussed, and that's very important to develop trust and transparency. And another field in this is human and other sensitive attributes, which we discussed. So you can see that some of the sensitive human attributes are highlighted here, like gender, socioeconomic status, geography, language, age, culture, all this. And when you have this well documented, it's very easy for someone to come and look at your data set and really understand what it's suitable for. Okay, let's look at model considerations now. So when we are building AI systems and we have looked at our data, we have understood the user's requirements, choosing the right model is very crucial. And your model will depend not just on the metrics of that task, it will also depend on the suitability. It will depend on the data set, and it will also depend on the need for interpretability or explainability. Sometimes a simpler model might be better, because it allows us to provide users with more transparency and more explainability. Complex models, while powerful, can compromise on this, making it harder for users to trust and understand the system. Another thing is model alignment. So model alignment it's a huge area of research, but then it's good to consider what alignment means for you in your particular application. Deriving from research, you can look at whether you need your model to be aligned to certain safety requirements and certain safety policies, which we're going to consider down the line in the next few slides. So we need our models to align not only with the performance metrics that we have decided, but also with some of the safety, fairness, transparency requirements that we decided while we were doing our user research. Now this alignment process, it can differ. So for LLMs, some of the alignment processes are you use prompt templates, right? And you make sure that the output is in a particular format, it's in a particular style, so you can use prompts to do that. Another way is fine-tuning. You fine-tune your model for specific factors like safety, for specific style factors as well. And you can use reinforcement learning, fine-tuning for that. The goal, although, for all these alignment processes remains the same. The goal is to ensure AI is responsive to human interests and values. This alignment can actually reduce harm and promote well-being and establish trust in the system. So it's a very important thing to consider, especially when you're developing Gen AI applications. Then model behavior testing is something that's very critical as well. So model testing is important both before and after fine-tuning, because you might be establishing a benchmark before fine-tuning, and that benchmark should not only assess task performance, but again, it should also align with your transparency and fairness and safety requirements. By understanding and communicating the model's limitations and biases, we can again build user trust like we did in data. Because the model may not be perfect, but then once you understand what the limitations of the model are, you can actually go ahead and communicate that as well. So ultimately, a principle-based approach to AI alignment, one that incorporates human values, fairness, and long-term considerations, will definitely lead to systems that are better aligned and humans can trust, and they promote human and social well-being. Let's look at some examples. So this is the language, it's the LLM interpretability tool, LIT. And what it does is basically, you can see that you have a prompt on the left, and based on the prompt, like the LLM might be responding with some answer, and you can see that what parts of the prompt are more important for it to decide its answer. So the ones that are darker, you can see that those are the ones that are more important, more salient, and the ones that are lighter are not. So it's not, again, something that I understand that a lot of us who are dealing with these models day to day and that are more technical might feel that this is not enough. And I would agree with that. But this is something that non-technical teams can actually use to test out some of the models, some of the prompts. And this really helps in iterating on your prompts faster, because you can look at what are the things that my model is looking at, what are the words that are important, what are the semantics that are important to it. And then you can try and iterate. Another paradigm that I would say this paradigm it's more important, or I would say it's more beneficial when you have a black box model and you don't have access to the weights of the model. But then if you have access to the weights of the model, there's a field of research called mechanistic interpretability, which is very interesting because it looks at the circuits of the neural network and looks at what are the neurons and what are the circuits at a small granular level as well as at a bigger level that get activated when we're talking about certain concepts, when we're talking about when certain inputs come up, and so on. So this is an example from computer vision, which was one of the earliest, I would say, the earliest areas where mechanistic interpretability was used, because you can see that these set of neurons are getting activated, the ones that are in red, when an edge is detected. So it's like an edge detector, and we've all seen that, I'm pretty sure, right? So these raw weights are the ones that are responsible for detecting an edge. And similarly, for large language models, you can use mechanistic interpretability to see what circuits are getting activated when you talk about certain topics. Now, my take on this is, right now, where the research is at, it's not super helpful for us as developers, because we may look at certain concepts, we may look at certain neurons that are getting activated, but there are a lot of challenges when it comes to actually using that to debug certain concepts. But this is an active area of research that definitely interests me. Now let's look at evaluation. And this is my favorite topic, because evaluation is something that we all do as software developers, as engineers, we all do that. But then I do want to talk about the different levels and stages of testing that are important for us to consider. So when we're dealing with AI systems, I think conducting evaluations throughout training and fine-tuning stages is very important to ensure models meet launch criteria and they can mitigate risks. So, of course, there are like different levels and stages to testing. You can start with unit testing, focusing on verifying that individual components and smaller parts of the system, they work well. So that ensures each part works as intended. But then integration testing, for example, in a RAG system, if your retriever works well and you have a LLM that is able to look at the data and generate the summary in a way you want, but then we also need to test the entire system end to end. So testing how different parts of the AI system works together is also very important. This is crucial for systems that rely on multiple models, multiple modules, for example, RAG. Then system testing is also very essential, because that is where you would test the end-to-end functionality in a fully integrated environment, ensuring that the model as well as the system performs as expected under realistic conditions. Now, so you can test for these things, right? But then we still haven't talked about how do we test for safety, how do we test for explainability, interpretability. So that would highly depend on your application. But then one paradigm that really helps is adversarial testing. So what's adversarial testing? It's basically creating prompts or creating inputs that you know are going to throw your system off. So basically identifying the vulnerabilities or unwanted behaviors of your system by testing it under adversarial conditions. Now, how does it look like? It basically involves people, experts coming together, simulating malicious or harmful inputs to test the robustness of the system. And for example, for LLMs, it could be prompt-based. So you just try and generate different prompts, try and generate different inputs, and the system is probed with adversarial prompts to uncover biases or uncover harmful outputs. There are actually automated tools for that now. So there is this research paper which is around AI-assisted red teaming. So what they do is they bring together different contexts. For example, they'll take a harmful activity, take a textual composition for that, and then take a geographic context. So like think about all the different permutations, combinations you can generate with that, and then try to probe the model. And this would bring out either certain biases against any geographical context or any communities, which is a really cool way to try it out. Then for evaluation, I use AutoRater a lot, which is auto side-by-side. So this tool is really cool because it provides side-by-side comparisons of model outputs, and I can do it for a bigger data set. And I can look at the trends in, let's say if I change a prompt in my application, and I'm using version 1 of a model and version 2, how does that compare? And it just allows me to look at it from a very broad perspective. It also can use predefined criteria. So you can define your own metrics, but it uses predefined criteria such as instruction adherence, grounding, comprehensiveness, etc., to provide consistent objective feedback. And another cool thing is you can actually put some of the human preference data here and then compare that to the LLM. That could give you some additional insights. Now let's talk about safety. So you have fine-tuned your model. You are pretty sure that you've tried to break your model and it works. But then safeguarding is still essential. Because even with prior tuning for safety, well-designed prompts, sometimes it's still possible for your model to output content that results in unintended harm. And that's why we have safeguards. Now, these system-level safeguards, what are they doing? They're basically filtering your input and they're filtering your output. So you have safeguards on your input where you're not allowing certain kinds of inputs to be fed into your system, and you have a default response to that. And you're also making sure if by any chance any harmful content is generated by your model, you're not giving that as an output. Now, how do you actually decide what input you're going to filter out and what output you're going to filter out? So that's basically based on governance. So this governance comes from system-level policies. So while designing your system, you might have thought about some policies, which can be content safety policies. They define what types of harmful content are not permitted in an online platform or the application that you're developing. So one thing is that your policies should reflect your application's use case. For example, an application that is intended to offer any ideas for family activities that might have a different content policy structure or different content policies compared to some other application, which is for healthcare, right? You can also use ready-made safeguards. So Shield Gemma is a set of models that can actually, so they're basically instruction-tuned models, and they're open, so you can train them, you can fine-tune them for your own content policies as well. But they are basically, they can help you determine whether the user-provided or model-generated content is sexually explicit, or it's dangerous, or it's hate speech, or it's related to harassment. So these are the 4 areas where it's been trained on, but you can fine-tune it for your own purposes as well. So with that, we are at the end of my talk, and I want to answer the question that I asked at the start of the talk. If the future of AI depended entirely on my choices as a developer, how differently would I approach my work? I think what I would do is I would collaborate with a more diverse set of people. Because I feel if I'm able to get a more diverse view on something that I'm developing, it's just going to develop better. And I see that again and again in my work as well. Collaboration always leads to just better outcomes. So I think that's one change that I would make. And then the other mindset shift that I would make even further is I would give myself the right to the agency that I already have. Thank you.
Do we have any questions for her? That's all right. Any questions, guys? Oh, beautiful.
Thank you for the talk. I was very interested in the tool that you had showed to, like that was the LLM equivalent of inspecting the activation layers of the vision tool, and I couldn't find it online, so I was wondering what the name of it was again.
It's LIT. So let me find the exact URL for you. It's the language interpretability tool. I think I might have mentioned it's LLM, but it's language interpretability tool.
Okay.
Maybe search that.
He's found it too.
Yeah? Okay.
Okay, thank you.
Oh, sorry, it's learning interpretability. Yeah.
Any other questions? Any more questions, guys? All good.
Cool. Thank you.